Perhaps 3D printing is done on demand. That's provided that you're that advanced, especially for slow moving or difficult to source parts. Can blockchain technology be used to communicate predicted demand with suppliers in advance? And another thing, that's if you are dabbling in blockchain, if you haven't, you really need to start moving in that direction. So no longer a dream, but this is a reality. During this innovative webinar, the question will be addressed: how can tomorrow be improved? And I think for the sake of all of our sanities, tomorrow definitely needs to be improved. This webinar strives to inspire the audience by making attendees aware of innovations in the field of spare parts management and maintenance, repair, and operations. The webinar provides input for a long-term improvement spare parts management roadmap, illustrating innovations for improvement in a practical way through the use of global case studies and discussion demonstrating the various opportunities. So we have an incredible lineup of experts joining us this morning. Willem Rustenburg, CEO of Gordian Logistics Experts from the Netherlands. I believe he's currently camping out in Cape Town. Johannes Coetzee, MD of Martec, Vice Chair of GFMAM, Advice Board for Department Industrial Engineering at the University of Pretoria. Sean Culey, founder of Sean Culey Ltd, Business Transformation Advisor, Change Agent, and inspirational keynote speaker, and author of Transition Point, From Steam to Singularity, from the United Kingdom. Incidentally, if you have not read the book, you do need to read it. Wouter Heijnen, is that right?
Wouter Heijnen, yes.
Okay, good. Consultant at Gordian Logistics Experts, the Netherlands. So this esteemed panel are going to take you through the points of the webinar and discussion. If you have questions, please put these into the chat and we will address these after the presentation. So without further ado, I'm going to hand over to the Gordian team and take it away. Thank you.
Okay, thank you, Tonya. I will take it over. As Tonya said, my name is Willem Rustenburg and I will be the chair for today's webinar. So thank you all on this webinar in the field of MRO and spares. And yes, it is a webinar, but it might feel more like a rapid experience. So hopefully you had some decent coffee already. We will expose you to some real innovations and make them as tangible as we can. But the purpose of this webinar is not only to share these innovations, it will also be about creating urgency, about societal relevance, about demonstrating that innovations are outside the scientific castles already, and about seducing you to put the innovation thinking in explicitly on your roadmap. But to manage expectations, what we present to do might not be something that you want to do tomorrow, but it might definitely be relevant for the day after tomorrow. So when we started this adventure on this webinar together with SAPICS, so thank you SAPICS for that, I was not completely sure how much interest this topic would create in the sub-Saharan market. But there is a lot, as you can see in all the logos on the slide, and we're probably not even complete. And we have over 90 people that registered for this webinar. So thank you for this great interest. And now obviously it's up to us, of course, to make it a success. On the practicalities, Tonya already mentioned it. If you've got any questions, comments, or just things you want to share, feel free to use the chat function. I think you're all familiar with that now. If there's any technical things, you can contact SAPICS via the number listed, or Henrico Zwaardenpoel, the co-chair of this session, via the email listed. And this information will be shared in the chat. After the webinar, you will receive a brief summary of this webinar with the highlights by email. And finally, please note this webinar is being recorded for internal evaluation purposes. So if that is anything of an issue for you, please switch off your camera. So now we go to the interesting part. Because innovations should be a means to an end. And what are the actual problems that we want to solve? Actually, they are not that difficult to formulate. Imagine we have capital extensive assets like trains, wind turbines, ships, airplanes, mining assets, production assets, etc., etc. And we have a supply chain with spares to support those assets in their maintenance. Well, the trouble is often that these assets, they may fail in an unpredictable way, creating the very need for spares. And we have lots of them. Our warehouses are full of spares, but often with the wrong spares, so maintenance is hampered by a lack of these spare parts. And that might in turn lead to situations where assets are down and they cannot do the primary function they are intended to do, so production might stop. Moreover, we often don't have a responsive supply chain with proper supplier agreements creating a solid backup. And finally, there is often insufficient decision support. Inventory decisions are made on belly filling. So in total, this situation that we often experience, not only in Africa, also in Europe, there's asset downtime due to spares, there's a lot of working capital, high supply chain cost, and many people unhappy. So how to make us happy again? That is the question that we try to solve with innovations. And just imagine we apply what we call a sense and response strategy. So we are able to sense condition information of machines, of operating conditions, of climate conditions, and we're able to transport all these enormous amounts of data via intelligent platforms, modern platforms like 5G to big data centers. And we have artificial intelligence algorithms to work with them, to create information on these massive amounts of data. And furthermore, we have a control tower that decides on this information and that can share this information using blockchain technology. And one of the people that we would like to share it, of course, is our planners, our spare parts planners, our supply chain planners. And we want to amplify their intelligence with that information. Or are these planners really needed? Can we replace them by computers, like by smartboards? Also, Sean Culey will briefly address that. But one way or the other, there must be an action plan. And an action plan is about getting the right part to the right place on the right time. For example, by using local 3D printing at devices and drone delivery. So this is the concept. And this concept will lead to zero downtime due to spares, low working capital, and low operational cost. And then that should make everybody happy, of course. But this concept requires more explanation. So I'm very fortunate we have a great team of presenters. They have been addressed already by Tonya, so I will not go into detail. But just on the structure, Sean Culey will give an overarching presentation on all the innovations. And I really love the way that he does that. Then we have a couple of specific innovations that will be addressed by Johannes and by Wouter. And Rico is my co-chair of today. He's my business area manager in South Africa, and he will take care of the last part of this session. So for the people that switched on a little bit later, this is the agenda for today. First of all, Sean Culey will start with his vision, his overarching vision on the innovations, and also he will create a certain urgency on applying these innovations. Then we have the 4 specific ones. And finally, it is very important for us to listen to you, to get the voice of the audience, what you think about all these innovations. Are we still dreaming, or are we coming close to reality? And that part will be picked up with Enrico. And finally, I will close with a couple of closing remarks. As I said, there can be questions. And after each presentation, if time permits, 1 or 2 questions will be selected, and we will ask the presenter to answer them. Okay, that's for now. Sean, you can take the floor from here.
Thank you, Jan. Okay, bear with me while I just share my screen. I can't do that at the moment. I just need to. And I'm going to share the sounds off. Okay. Good morning, everyone. Mind you, I'm just going to very quickly get rid of this message just popped up on my screen. Good morning. Right, I'm going to take you through a bit of an overview, as said, on what's actually happening across the sort of industrial space with different technologies, and importantly, I think, why it's happening. I know some of you may have seen a little bit of this before, because I have spoken a number of different SAPICS events. But I want to just start with talking about the disruption that we're going through right now. So the term VUCA gets used a lot to describe, this sort of very disruptive nature of the industrial world right at this particular moment. And it's a military term that was co-opted by the consultancies, I guess, around about 2010, I suppose. But it stands for volatile, uncertain, complex, and ambiguous. And one of the things that's always intrigued me, and one of the things that has led me to certainly write my book, was to try and really understand why it was VUCA, because no one really explains that. It's like we use this term all the time. Everyone sort of agrees that it's incredibly disruptive right now. It's more disruptive right now than it seems to have been throughout our lifetimes, but no one really questions why that's the case. Now, in my research for my book, we delved into what's actually driving these changes, and the predominant force is something called Kondryatov cycles, or long waves of creative destruction. Now, the upswing of these waves is driven by the entrepreneur and their innovations. And you will see that although this is quite a nice even sort of bell curve we've got there, in reality, it takes up about 65% of the wave cycle. Now, one thing to bear in mind is these waves are about 35 to 50 years long. And so we're expecting this disruption not to, to calm down anytime soon, but actually we've got another decade worth of it. It's now going to begin to speed up as a lot of the different innovations that we're seeing, we're going to talk about this morning, start to mature, start to make the way into the market. Now, we've had 5 different previous waves of creative destructions. And one of the things that I identified as I went through and looked at the different technologies is that there's 3 predominant sort of what they call sort of super innovations that are driving it. They're usually super innovations in the form of power, in transportation, and in communication. And combined, they create new industries. And the nature of creative destruction is such that as they create these new industries, they ultimately destroy the other old ones that were wedded to the old and now replaced methods of doing things, either the old power source or the old communication mechanism or the old transport mechanism. So, for example, the automobile revolution, completely decimated the industry for buggy whip makers and carriages and horses in general. One of the interesting things I found is that actually these waves are getting stronger, faster, and more disruptive. So the frequency between them is increasing. So there's a shortening of time between the different technological waves. There's a massive increase in the amount of innovation that's been generated per wave, mostly because there's more countries and more brains being involved. The rate at which these innovations spread across society and national boundaries is incredibly speeding up. If you imagine back in the first wave, innovations traveled the globe by sailboat. Now, of course, they travel by fiber. So that, the moment something's been invented, it can be the other side of the world instantly. And of course, the scope, the increase in the number of countries and therefore the number of brains being involved in creating the innovations, but also a scope in the number of countries that are affected by the innovations. Now, the impact of this more increase in speed means that we're seeing a shortened lifespan for the S&P 500 companies. So the companies that are at the top are being at the top for a lot less time. If we look back to 1955, back in the 4th wave, we can see that the average lifespan of a company in the S&P 500 was 61 years. In 2015, that had dropped to 17 years. Now, one of the interesting things is that if you'd actually look at the companies that were leading each one of those waves, the nature of the industries that have been involved have changed, but also their value. So each one of the new companies is increasingly generating more value. So if we look at 1917, just after just before the First World War, the US Steel was the biggest company in the world, and it was worth 46 billion. 50 years later, US Steel didn't feature. But interestingly, the number 10 company in the list was worth more than the number 1 company was worth 50 years earlier. And then that trend repeats again in 2017. So if you look at IBM in 1967, it's worth 258 billion. and you look at Wells Fargo, which is the 10th biggest company in the world in 2017, it was worth 266 billion. Now, as we're in this upswing, the value being generated around new innovators is exponentially faster than before. So if we look from 2017 to 2021, an incredibly small period of time, Apple's still at number one, but its market capital value has gone from 898 billion to 2.1 trillion. Saudi Aramco has just had an IPO, so that's just how highly valued. Amazon's value has gone from 543 billion to 1.6 trillion. Alphabet's gone from 709 billion to 1.3 trillion. Companies like Tesla have had an exponential growth in their market value, although it's starting to crash a little bit at the moment, but it reached 852 billion. And we're starting to see Chinese companies on this list like Tencent and Alibaba and TSMC for the first time as well. So there's a change in geographies and a change of industries as to where this wealth is coming from. Now, as I said, we're in the most disruptive period right now. We're in the upswing. And the reason why it's disruptive is because we've got all of these different forces happening at the same time. And one of the really interesting things is, for the first time ever, there isn't a kind of an industry sector that is getting away from it. In the past, you could see disruption was impacting certain industries, whether or not it was impacting the automotive industry or the oil industry or whatever. This time, the digital nature of the technological disruption in this wave is affecting every industry in every geography all at the same time. Why is it so disruptive? Because we're in the transition between the old and the new. The old is still here providing jobs and income right now, whilst the new is being developed, ready to roll out. So for example, we still have a large number of people still earning a living from driving goods around the country. But we know at this moment in time, companies are working very hard on creating trucks and cars and vans that are autonomous, who will replace all of those jobs. And because of that, this is why this part and the process is the time where not only is it the most disruptive, it's the most dangerous. If you look back through history, all of the revolutions, all of the major social uprisings happen at this point in the wave cycle, because there's a power shift between the old and the new. And because people with capital can invest in the new innovations of this wave, they're able to make huge amounts of money. And that generates a wealth inequality, which most people actually don't like to see. However, there is positive news, because for every wave that's happened so far, we've been able to make social recalibrations to adjust to this new reality, so that the number of winners outnumber the number of losers, and those who are the losers effectively are seen to and looked after, so that we can move forward into a new golden age. And we should expect to move forward into this new golden age, because it will emerge, and it'll be a digital belle epoque this time round, a new digital golden age. But it is a time of power battles and paradigm shifts. And the supply chain is a really interesting area where to look, we can see some of these paradigm shifts taking place. One of the most important ones is the fact that we've moved from the company being in control to now the consumer being in control. We've moved from goods going through a single channel that they were in control of to an omni-channel that the consumer's in control of. From physical shopping to online shopping. From the consumer traveling to the retailer to now the retailer having to deliver to the consumer. And therefore, we've moved from linear push supply chains to cyclical pull value chains. We've also moved straight away from products to actually more services and experiences. And the new breed of consumers, the millennials and the Gen Zs, are rejecting ownership in favor of access. And we've also moved away from humans, there should be females as well as men there, into machines. So we've moved from this supply push product chain into customer-centric valued networks. And I particularly like this quote here by Mark Engels, who's the Chief Supply Chain Officer of Unilever, who said, "Supply chain is no longer a chain. It's a circle with the customer at its heart." To adapt to this, resilience has suddenly emerged as a strategic directive for most organizations. Now, it's a word that gets thrown away a lot, but what does resilience mean? It means the ability to understand and withstand the unknown, the ability to sense, to respond and adapt without falling into chaos. Because previously, disruptions were unlikely in the downswings, and when we had most of our supply chains were relatively localized, disruptions were rare, but now they're a certainty. Major shocks are becoming a norm, such as, obviously the pandemic, but also things like Brexit, the US and China trade wars, etc. But what we found is in the downswing, the leaning of the supply chain and the driving out of all the costs and the offshoring of it have left it perilously exposed in the upswing. Because the offshoring, of course, has exposed it to more risks and also longer lead times and less flexibility. Because of this, global supply chains lack global resilience, and they're breaking down in the face of multicultural disruptions that they simply weren't used to. Supply chain operations are becoming more costly and now represent a company's highest costs. So supply chain has gone from something that the CEO wasn't particularly interested in to something that's actually at the forefront of their agenda. Now, as we saw in the downswing, most companies focused on cost control, but we're now about to be in the upswing for the next decade. And cost control requires a high degree of predictability. And quite frankly, we don't have a high degree of predictability right now. Now, luck is at hand because technology is coming along to try and help us here. And as I say, we're right at the start of this upswing process. And we've got a number of deceptive technologies that we've seen viral videos about for a number of years. They're soon about to cross the chasm and become very disruptive. And it's going to create something that I named the creative disruption triple whammy. And I've been talking about this for a number of years now, but whammy number one is the effective replacement of everything that we do with the things on the end of our wrists, and the sweat on our brow with machines. So the automation of physical tasks, specifically those that are rules-based and repetitive. Whammy number two is vertical convergence. So this is effectively the thing that has most companies and most people spooked. It is the replacement of cerebral activities with machines and the automation of knowledge-based tasks. And whammy number three is the convergence of machine brains driving machine hands across the end-to-end supply chain. And you're therefore driving a completely automated end-to-end supply chain. If we look at whammy number one, what do we mean? So we go from source all the way to sell, and you can see that there's a variety of different technologies that are doing everything from picking fruit out of the field or strawberries out of the ground, things that we used to assume that only nimble human fingers could do. They're driving trucks in mines. We're building fully autonomous shipping, fully autonomous planes. Ports are now becoming fully autonomous. Rotterdam was the first fully autonomous port, but now every major port in the world has an automation plan. In manufacturing, we've moved from robots being single purpose, big, dangerous, expensive things that you used to have to put behind cages, into collaborative robots that are multi-purpose, that can change what they do basically by selecting different software or different apps or different grippers on the end of their hands. We've got 3D printers that can now print incredibly complex things, incredibly detailed and precise elements in things like titanium. We've got new types of 3D printers called carbon printing, and I'll show you a video on that in a moment. We've even got 3D printers that can print things as large as houses. In the delivery area, we've moved from automation not really being involved in that process. It's always needed human hands to pick, pack, load, put away, drive car vans, etc. to fully automated warehouses, automated lorries, automated delivery vehicles such as drones or road robots, and even the combination of vans and road robots going together to create suburban motherships, mobile warehouses that move into areas that are longer in range than the robot can handle on its own. In the cell area, we've moved from the thing at the top there, which is a virtual display of a shop on a subway station where people can simply order products by taking a scan of the 2D barcode that's against the image, through to the release of shops that don't require cashiers. And in fact, last week in the UK, the first Amazon Go store opened in London. We've seen robots such as Pepper, which are multi-purpose, a bit like Baxter previously, which can do many things depending on the software that's being loaded onto it. It can work in retail, it can work in museums, it can work in airports. It can do pretty much everything a human assistant can do, but it can do much more. It can capture data about every single interaction. It can present information on its chest tablet. So they're defining this multi-purposes for these types of humanoid robotics. Beneath that, we have the FBI listening devices such as Amazon Echo, which most people foolishly have in their houses now. And beneath that, we even have the capability of machines to order their own replacement parts via little pieces of code. And that thing is called Amazon Dash Replenishment. But these technologies are enabling us to redefine the factory and even do things like mass customization on demand.
Design, deliver. With Carbon, you can design, engineer, make and deliver end-use parts all in one system of connected products. We call it the speed cell. And with it, we are redefining how products are made, transforming impossible concepts and designs directly into end-use parts at any scale. Make the impossible. Carbon allows designers and engineers to create freely, simplify complex assemblies, produce unmoldable lattices with the widest range of mechanical properties found in additive manufacturing. Anything is possible. Design it, engineer it, make one, make a million. With Carbon, make any number of end-use parts economically equal. A factory for each part, every person, at any scale. Innovate at the speed of thought by designing on the means of production. Dramatically compress product development timelines and greatly reduce expense over a product's life cycle. Carbon is making the impossible at scale, unprecedented flexibility and iterative speed. Speed Cell and Carbon's next generation additive manufacturing tech will redefine your business. Stop prototyping. Start producing.
That was Carbon 3D printed that produces solid objects out of liquid using what I like to define as magic. But these types of technologies are enabling a reshoring revolution. We now have robots, for example, like the Sobot over here, that's able to make as many shirts per hour as 17 factory workers, which means that companies that were previously exposed to bad headlines about labor practices in places like Bangladesh, where they make most of the apparel, are now able to rethink that and say, actually, we can move manufacturing back to close to where the consumer is, but use automation in order to keep our costs low. And this automation is so fast and so flexible that actually it can change its production cycle basically by a simple, click of a button. We've got companies like Through Six there that's expanding its distributed on-demand manufacturing model. We've got Amazon in the middle that's had a patent for an on-demand clothing manufacturing warehouse for pretty much 6 years now. And we've got headlines saying that the global supply chain disruptions are driving robotics adoption because of what's happened with things like COVID. The logistics revolution is about to occur. Most of these technologies we have seen, like I say, on videos or in small amounts, most of these are going to cross the chasm in the next 12 months. Drones have already got FAA approval across the US and in the UK. Autonomous trucks like the Volvo Vera up there are likely to be seen on the road pretty soon. Road robots have gone exponential, in specifically in the UK and the US. You can now see these in many different cities. Agility robots working with Ford to develop a robot that actually delivers goods from the back of the van to the front of the door. I talked about motherships a moment ago, the collaboration between Daimler and Starship Robotics. And in the middle there, we've got companies such as AutoStore that are building this ASRS, or automated storage and retrieval systems, which effectively is completely redesigning the inside of the warehouse and using the vertical space as much as the horizontal. Now, what we're seeing is COVID has provided rocket fuel for the automation revolution, and it's exponentially exploded it. So I talked about Starship Robotics a moment ago. This has been their growth path in terms of the number of deliveries. And they'd only done 5,000 by September 2017. That had grown to 50,000 by April 2019. And by June 2020, just after the start of the pandemic, it had grown to 500,000. But in just 6 months, that doubled to 1 million. So they're on an exponential curve, because once this technology crosses the chasm and people get to see it, get used to it, trust it, suddenly it creates competitive advantages, and other companies such as Amazon, for example, are racing to bring out their own equivalent innovation. So tomorrow's workforce is beginning to look a little bit like this. And one of the things that makes this wave different to all the previous waves is that these robots aren't just replacing human jobs like the automation of the previous waves. They're actually replacing human capabilities. They can see, they can hear, they can speak, they can translate, they can pick, pack, load, do anything pretty much we can do. And they're getting smarter all the time. Now, the reality of the 6 waves upswings, and one of the things that we've found is because of all of this disruption and this unpredictability, humans are too slow, our forecasting is too inaccurate, our planning cycles are too infrequent, black swans are becoming far too common, human behavior is just too irrational, and consumer expectations are too demanding. And what we're finding is that we need supply chains to adapt and react in real time, which leads me nicely onto whammy number 2, the automation of the knowledge worker. So we can forget things like forecasting because the future no longer looks like the past. So doing things like using corrected sales history just doesn't cut it anymore. And we're using things like machine learning in order to do that through supervised learning, where we're training the machine to look for certain patterns, through the things that we can't do through unsupervised learning, where we're basically allowing it to work on unstructured data sets to find trends that we simply won't be able to do. Well, we're seeing a number of different companies like Merck and like Amazon to use these to identify, non-linear relationships that simply are too difficult for humans to identify. Now, these self-aware cognitive supply chains are using these types of tools to go through 4 levels of maturity. Level 1 is what I call descriptive diagnosis. So it's the ability for the machine to effectively tell you what's going on in your supply chain. That's helpful, but not particularly useful. It's a bit like saying, it's telling you that you're stuck in a traffic jam. You knew you were stuck in a traffic jam. Now, level 2 gets a little bit better because it's warning you that there's traffic jams up ahead. It's warning you of potential issues in your supply chain. Level 3 is really where we want to be, however. I don't want to know that there's likely to be a blockage in my supply chain. I would like some help about what to do about it. And level 4 is a fully self-driving, fully autonomous supply chain that not only identifies potential issues, but automatically adjusts and adapts to those issues, making its own decisions. So level 1 and level 2 is effectively humans making decisions using data from machines. Level 3 is humans making decisions using recommendations from machines. And level 4 is machines making the decisions and then reporting to the humans afterwards. The really interesting thing that most people don't realize is we're already at level 4. So there's already systems like ERA that are able to fully automate parts of the supply chain, and companies like Merck Healthcare, for example, and they've already announced that they've got 60% of their product range fully automated. And how do we interface with that particular autonomous supply chain? By voice, the same way as we interface with humans. We simply ask it questions. Now that gives us a bit of a problem, because as we go through this, the number of data inputs are going to continue to increase exponentially. And machine brain power is also improving exponentially to adapt to that. But as Homo sapiens sapiens, our human cognitive capability remains relatively static. So, for example, systems such as ERA already track whether or not any supply chain recommendations they issued were followed, and whether the human intervention improved or worsened the outcome. And what companies like J&J and Merck are finding out is that human biases, limited cognitive power, and our attachments to past knowledge are basically bottlenecks in the cause of bad decisions. Basically, every time we intervene, we tend to make it worse. So right now, companies are kind of insisting that these AI systems are glass boxes, that we can see how they actually came up to the calculations they came up with. But pretty soon, we're going to change that and say, do you know what? We don't even understand how you came to that decision, even though you tried to explain it to us. And we accept that you were correct. So once we trust the algorithms and the outputs, our supply chains will become ever more autonomous. So we're going to move from the 5th wave model, where we develop and design products, we make some money off it, and then we capture the information afterwards and analyze it in the rearview mirror by recording transactions, to where actual data and information is deciding what products we should make, and then we're making money, where we're being driven by insights. So we're ending up with a model that looks a little bit like this. It looks a little bit like the diagram at the start. Robots will do the making and moving, blockchain will do the recording, robot process automation will process the transactions, digital assistants will handle the queries, and AI control towers will analyze the data, identify issues, and recommend solutions. But the interesting thing, all of those technologies are basically on their own exponential curve. AI, robotics, autonomous vehicles, all of those are about to explode. And we haven't seen anything yet, because things like quantum computing are about to hit the market. Google achieved quantum supremacy by solving problems using its quantum computer program called Sycamore, that effectively agreed that the most powerful supercomputer in the world would have taken 10,000 years to solve. And companies like Volkswagen are already seeing a use for this kind of power by being able to control the sort of volume of autonomous vehicles as they go across the roads, You know, imagine the amount of data that's being passed through to these systems in real time. Somehow we need to analyze and make, you know, nanosecond decisions, and that's where quantum computing will come in. Now, it's interesting to note that quantum computing is actually increasing at a speed far greater than Moore's law. So this was Moore's law, which has driven all of the progress so far in the computing age. And this is Nevin's law, which is operating at a double exponential rate. And so we have no idea what quantum computing is likely to do, but by the speed of progress, we're likely to find out really quickly. Now that leads me to whammy number 3, where machine brains are driving machine hands. We end up with a picture that looks a little bit like this. In the center, we have all these planning and control systems driven by artificial intelligence that is connecting together devices in manufacturing, in goods transportation, in product design and visualization, in the transactional process and back in that ERP, and even down in data capture. Then they're all being connected, all being processed, all being analyzed, and being turned into a decision that we can make sense of. Now, what's going to drive the Internet of Things revolutions moving forward is going to be 5G. And 5G is on its own exponential path. You know, this will cover 65% of the global population by 2025. That's far faster than 4G was rolled out. So we're going to see 5G, you know, start to really appear this year. I mean, it came out last year and it's back in 2019, but it's been very minor in its adaptation. But most companies want 5G because they want to connect these devices together. Because what they want to connect is a whole host of sensors in a number of different industrial things, everything from wind turbines to trucks to 3D printers to robots, all the way through to consumer devices such as watches, your washing machine, microwave, and even your thermostats. So we have a whole host of devices in the industrial world connecting with a whole host of devices in the consumer world and capturing data from all of them, being able to process it, make sense of it, and make real-time adjustments based on that information. What is coming together right now is a merging between the physical world and the digital world using augmented reality and virtual reality. And that's enabling us to create what I call digital doppelgangers or digital twins that peel back the layers of the physical world, allowing us to replicate it in a digital environment where we can do, you know, we can monitor things, we can do predictions, we can do simulations based on the information that's being received from all of these different sensors. Companies are combining together these different technologies into things called modular manufacturing or factory in a box concept, which is allowing them to build fully automated little factory units in things like shipping containers and just simply move them to where they're needed rather than to have to break ground on really expensive factories before they know whether or not they've tested the market or not. So we're moving from a world where the supply chain is invisible. It's not on the CEO's agenda. He's not really interested as long as goods just get to customers, to where the supply chain becomes incredibly visible and transparent. What do I mean by visibility? I mean visibility in the flow of products, obviously, but also information and also finances. That's going to provide visibility to the supply chain's consumption of energy, of water, of waste across the 5 different areas from, you know, movement to inventory, so that we can identify the different weak spots and risks in the supply chain. And that gives us visibility of the supply chain's impact, its ethical impact, its ecological impact, and of course, its economic impact. Now, visibility across the supply chain is also the key to the thing we talked about at the start, resilience, because you cannot understand what you cannot see. You can't control what you don't understand, and you can't improve what you cannot control. So the reverse of that is true. Visibility will enable understanding. Understanding enables control, and control will enable constant improvement and innovation across the end-to-end supply chain. And we end up, therefore, with something that looks like this, what I call the PAL supply chain, a personalized supply chain where product, service, and experience are designed specifically around the individual. Fully automated end-to-end supply chains, and much more local ones with local production, local logistics, and local retail rather than massive offshore and very, very slow supply chains. And the stronger, the more sustainable, the shorter the supply chain is, the more stronger, more sustainable, and more agile it is. You see, the future is looking nothing like the past. It may have been plain sailing and relatively predictable in the past. It's not going to be in the future. It's certainly not going to be for the next decade. And we need to watch out for the cultural lag, because while technology is changing at an exponential rate, us humans, our people and our organizations, change linearly. So we have to look to advice like this. Mark Twain's quote I find is particularly pertinent. It ain't what you don't know that gets you into trouble. It's what you know for sure that just ain't so. And then Alvin Toffler gives us wise advice where he says, the illiterate of the 21st century will not be those who cannot read and write, but those who cannot learn, unlearn, and relearn. So I say to you, the best way to predict the future is to create it. Thank you very much.
Thank you very much, Sean. I appreciate it. It's always great seeing a master practicing his art. Your understanding and passion for innovation makes me happy. I believe I'm one of those that will have to learn how to adapt to this new future. We're now going to make things a bit more practical by discussing 4 specific innovations: IoT, specifically condition monitoring, artificial intelligence, blockchain, and 3D printing. It is my pleasure to introduce Johannes Coetzee, the MD of Martec, to discuss the first innovation, IoT, looking at condition monitoring and the effect of failure detection on spare part management. Johannes, over to you.
Thank you, Riku. And yeah, I'm sure, Sean, first of all, thank you very much for that presentation. I'm sure there's a couple of people that's still hyperventilating about the thought of keeping up to all the developments. So as Enrico said, I'm going to try and make it slightly more practicable and explain to people that help is at hand. So let me share that, and I'll give it a few seconds to get through and start talking in the meantime. So I think the main thing for us is 100%, as Sean has indicated, the technology is moving at a fast pace. And companies could start worrying about, how to keep abreast. And obviously, it's not a question of whether you want to, you have to if you want to stay competitive in this game. Your competitors are definitely not going to sit back and they're going to reap the rewards. But there's help at hand. There's many companies that's really building practical tools and bridging this gap between where the technology is moving and where companies are currently finding themselves still. Martec is one of those companies, Gordian, etc. There's quite a lot of good work that's being done, and I'll give you a sneak preview in a very small sector, condition monitoring. And literally, with the time to my availability, I'm just going to give you a teaser effectively. But as an engineer, no respectable engineer can do any presentation without referring back to technology. Theory. So let me show you just a little bit of theory that I'm going to base the presentation on today. Now, my apology for those of you that know the PF curve intimately. I'm just going to do a bit of an highlight overview, and then I'll get to the point of the slide. So the PF interval effectively is between the point of failure, where the first signs of failure is on the machine, to the point where it fails. And we put this on a graph that basically tells you the asset condition and the usage time. So as you use a piece of asset and equipment, as the piece of equipment gets older, the likelihood of it failing, or at least the level of reliability, becomes less and less proper. And so what we're trying to do with condition monitoring is to detect as early as possible the first signs of a piece of equipment, or then a subcomponent of that equipment, starting to fail. Because the more time you give yourself between the point of first identifying a potential failure to the point of failure, and even better, predicting when that failure will be in the future, obviously that has massive impact on your supply chain and a number of other aspects around engineering. So the goal of the exercise, in particular, the advances being made with the industrial Internet of Things, is that we actually effectively able to move this point P, which is the first point at which you see something potentially failing. You can move it earlier. Now, what do I mean by that? I'll get back to the benefits. So if we go back down this curve right to the bottom, catastrophic failure, which is obviously the type of things you would want to avoid. That is your typical breakdowns that nobody expected, and people have to rush around to try and figure out and fix. You want to move this point back, and you use technology to do that. Before we just focused on corrective maintenance, then we moved over to preventive maintenance, and that was very much putting the human into play and making sure that the human inspected the piece of equipment on basic principles. And those were, to a large degree, the senses that humans possessed. Then we started moving further on with condition monitoring, where you started analyzing the oil, and the analysis of the oil would be able to tell you. You could take vibration measurements. That will definitely tell you something. Ultrasound came onto the market, and granted, not all of these technologies will be applicable to every failure mode, but it's just to give you an idea, where we are. Previously the statement, for instance, in electrical equipment would have been that you can't do preventive maintenance on electrical equipment. They basically run till they don't run anymore. And that has since been proven wrong, especially on the medium voltage and high voltage equipment, which is very critical to most plants. You can imagine if your incoming cables go, or your transformer or switchgear goes, there's sizable parts, if not the whole plant, that shut down, and depending on the lead time to fix those, could be detrimental effect on your performance. Now, things like partial discharge, for instance, in electrical, has really helped us to move this point P even further into the future. Right, enough about the technology. I'll come back to some of the technology that can be used. The point is, we can now take this point P and we can move it closer to us, so that we have early warning effectively of an item happening. And what that does, it increases this window of opportunity where we can actually react to the problem. So by looking at the window and by increasing the window of opportunity, that actually has massive impact on especially the supply chain, and I'll come back to a summary slide on that. But we also want to do with better analysis and better understanding of the failure, move the point F. In other words, the point where it's functionally failed, you want to move that into the future, so further away. So you want to lengthen the life of the asset by means of picking up what is wrong and potentially doing some sort of a corrective action or a preservation action, so that you can get the maximum amount of life out of these assets, and obviously get the maximum amount of return on investment from those assets. So that's, I think, enough for now about the theory. Let me look to some of the practical things. And what I'm going to do different from Sean in this case is I'm going to show you very practical things that we're currently doing and that's running. So it's literally off the shelf. You can put it in and you can run tomorrow, and take you through some of the advantages that has been raised in the field. The first one, and a very basic one, is standby power generators. In South African context, at least, we understand the criticality of these. With electricity supply not normally being a given, many plants rely on having a standby generator. And one of the basic things of a generator is that ideally you want that thing to have a charged battery and a full tank of diesel when it's needed. The worst case scenario is the power goes out and the battery is flat. You can't get the machine to start automatically, or there's no diesel, or it runs out of diesel shortly into the shut. So basic things, by monitoring the diesel, not by a human going to look at what is the level of detail, but to actually have a sensor that tells you exactly how much diesel is at any given point in time in the tank of that generator, feeding this back to an information management system, and more importantly, actually being able to link this to, for instance, your enterprise asset management system or your CMMS, so that it can create a work order that somebody has to go and fill the diesel, or even better, link it into your supply chain, that it automatically places the order so that the company or a subcontractor goes and refuels the generator. Automatically happening. No longer needed for a person to actually open a paper or create a piece of PO. This could be completely automated, for instance, like links into your enterprise asset management SAP systems, JD Edwards, a number of other systems. Moving up in the scale in terms of assets, dump trucks, mining. You can do basic things like monitoring the tire, the pressure in the tire, which is obviously early warning. You want to make sure that you don't run tires at low pressure because that will damage them, but also going into a lot more detail about the engine itself, the temperatures that it's running, and even down to operator efficiency. So a lot of information that can be gathered from these type of assets that perfectly relates back to giving an idea to the supply chain of what is required at what stage. Mechanical stuff like fans, motors, protecting this by measuring the vibration of that fan online and having alarm levels triggered when that vibration goes out of spec. You can actually have it rebalanced, and in that way you actually save the motor and the bearings in particular on that motor, giving you a much longer life on that motor, saving you money, reducing the stress on supply chain. Moving up, scaling up, still mining again. If you look at ball mills, looking at the electrical side of that ball mills, but also the mechanical side of that ball mills, real-time information with the necessary controls in place alarm levels automatically triggered, and those alarm levels can either first go to a specialist to interpret or directly trigger the necessary action in the enterprise asset management system. So once again, gaining time, because now you're not depending on somebody to go maybe there once a week to go and inspect. This is happening all the time, real time, and as soon as the alarm is triggered, automatically the information is in the enterprise asset management system, and you win at least a week, and depending on what the frequency is that you inspect, you know, some of these electrical items would only be inspected 6 monthly. So you win a lot of time that you can use effectively to supply parts and get the necessary components, especially if they have to be logistically transported or imported from different countries. You know, so you gain a lot of time to make your supply chain a lot more efficient. Interesting things also, just from a transformer point of view, when we spoke of oil analysis, we can actually put a little laboratory, which is a little box, not much bigger than a shoebox, connect that onto a oil field transformer, and it continuously does oil sampling of not only temperature of the oil, but also the moisture in the oil and 8 different gases in the oil. And each of those gases and the appearance of those gases indicating a different failure pattern. So you can really start to predict when a transformer will fail, and you can also potentially shut it off before it fails so that you can conserve the transformer and hopefully revive it again. As you will know, depending on the size of transformer, you could look at serious lead times to replace a transformer, and this is not typically the stock item that you keep. So this will have a detrimental impact on business if your transformer, for instance, fails. Yes, they're very reliable and they run for years, but nothing runs forever. So what is the beauty on this is on critical transformers, we can actually do real-time oil analysis and understand at any given point in time what the condition of that transformer is. Current technology can do it today, doing it. All the pictures, by the way, that I'm showing you are actual screen grabs from current implementations that's running live at clients. So to summarize, the impact on the supply chain and the management of supply chain, and specifically what that window of opportunity buys you, is number one, improved asset lifecycle. So you can make assets and subcomponents of those assets last longer, so increasing their useful economic life, which reduces the pressure on supply chain, but obviously has a massive impact on cost reduction in not just operating costs, but also on your CapEx requirements. And the same is true of subcomponents as well. Many subcomponents that previously would have had to be kept as supply, you could reduce that supply levels by managing those components better and making them last longer. Bringing me to the second point, reduced inventory levels, because you have better clarity on when certain items could potentially fail, and you give yourself early warning time. So by increasing the reaction time that you require or that you have, you can actually reduce the amount of stock levels. Now, yes, this is a very general statement, but in a lot of cases, this is true, where you can actually then reduce the amount of stock that you keep, because your probability of running out of stock is less because you've got more time to actually react. Same with consumables. I gave you the example of diesel. There's many other wearable items that you can measure, and you can actually have a very clear idea of when it will run out or when it will need to be replaced, thus giving you a very clear indication of what your demand pattern will be. And then the last thing is on the reduced insurance stock. For the same reason that you have much better information and a clear ability of understanding what the risk is in each of your components. Obviously, those that's monitored, not everything is practically and economically monitorable at this point in time, but you will have a much better idea on your critical assets and your critical components, what the risk factor for them is to fail in the next week, in the next month, in the next 6 months, etc. So you've got a much better understanding of the risk, which means you could potentially reduce your emergency stock to lower levels, which obviously has a massive impact on cost savings. So just in a summary, there's many other benefits, and I can talk probably for hours about this topic, but I just wanted to give a little bit of a teaser today to say things are practically possible. And yes, the future looks scary. The future is not necessarily as far down the line as you think. The future is here. The future is practical, and it can be implemented. I thank you, Chair.
Well, thank you, Johannes, for this interesting insight in the practicalities of condition monitoring. I'll try to share my screen and continue. Yeah. So, as Johannes just showed, that And Sean as well demonstrated that more and more data is being gathered nowadays, either by implementing sensors into our assets or in one of the many other ways in which we expand our data gathering capabilities in this increasingly digitized world. So having access to all this data is very nice, but how can we use this data in a productive way? Well, this is where artificial intelligence and machine learning come in. As artificial intelligence is able to process huge amounts of data to make predictions or recognize patterns in ways humans are just not able to. This strength of AI is exemplified by Blue Dot, a company that specializes in the development of AI to predict the outbreak of infectious diseases. Using social media data, local news reports, and flight records, they were able to predict and warn about the outbreak of a new unknown virus, then unknown, now unfortunately very much known, more than a week earlier than other established institutions such as the World Health Organization or the Center for Disease Control in America. Well, in the artificial intelligence and machine learning also have a lot of applications in the service logistics world. Three of the most promising capabilities of AI for service logistics are the classification, pattern recognition, and the complex problem solving that it's able to do. These AI capabilities can be applied in service logistics to, for example, detect or classify peak demands, or use pattern recognitions to predict future failures using past failure data or asset usage data, for example, gathered using the Internet of Things, as just demonstrated by Johannes, or lastly, to facilitate a supply chain control tower in which supply chain-wide decisions are taken by a centralized authority using all of the data gathered in the supply chain and supported in its decision-making by artificial intelligence. Well, as you can see, there's a lot of interesting use cases for artificial intelligence, but how does it work? How do machines learn? Well, there are several ways, but they can be generalized into a training phase, where the algorithm uses existing data and the resulting outcomes to learn or be trained to recognize patterns, for example, by reviewing labeled data. And secondly, a prediction phase in which a trained model is used to predict. To see these phases in action, we can see, I will show you a practical example at an aircraft manufacturer or repair vendor. And they have started recently to use machine learning to predict the risk of obsolescence in parts. So feeding the machine learning algorithm historical information on, for example, the development of the lead times, the development of price or minimum order quantities, succession rates, etc. And the subsequent resulting obsolescence of a part, the algorithm was trained to recognize these patterns that indicate the progress of the life cycle of a part towards its obsolescence. This allows the aircraft manufacturer currently to sooner recognize these patterns and foresee obsolescence risks earlier, which lets them take the necessary precautions. Well, shortly onto a more practical innovation, or an innovation that has a more direct physical impact on the world of spares, by really changing the way we produce or even source our parts, additive manufacturing, or as it's often called as well, 3D printing. Well, at first, 3D printing was seen as a bit of a gimmick. So some early adopters could print some plastic toys in their living room, but the business applications were limited at the start. However, through research and in printing techniques and materials, as Sean showed as well, it is now possible to print a wide range of objects with an equally wide range of different materials. So from the well-known plastics with which it started to different types of metal or even combinations of metals or other materials, and even concrete. Sean already gave the example of printing a house. This is a GIF of the University of Eindhoven in the Netherlands printing an entire bridge. And this was the end result, the world's first 3D printed bridge. which can now be visited in the south of the Netherlands. So if you're close, just come by. Well, back to the world of service logistics. The main benefit of additive manufacturing is the localized production of spare parts. So producing spare parts locally has several big benefits. First, it may eliminate or at least reduce the need for your local inventories for printable items, as parts can be printed on demand. So if something breaks down and you know what you need, you can print it on demand. Secondly, lead times are greatly reduced, as printing a part is often much faster than ordering a new one from your supplier. And thirdly, uneconomical minimum order quantities, which you are often subject to in the spares world, unfortunately, are eliminated, as there's no need to print more than you need. Well, other interesting applications can come from printing obsolete items, so that the items that are no longer sold by your suppliers, that you can print to keep your older machines running, or to make a temporary stand-in part or solution that can keep your asset running while the full replacement is on its way. This last application was also often used in the case of the Dutch defense. So both the Dutch Army and Navy are currently using 3D printing on missions. So they take a printer with them physically, and their research shows that this has a great benefit. So for example, for cost reduction, this is mostly attributable to the fact that these missions often take place, of course, on remote locations where supply is irregular or slow, such on a mission in Mali or on the open sea, even in the case of the Navy. And by using 3D printing, they saw that asset availability greatly increased, while the limited storage space, especially on board of Navy ships, as you can imagine, was way less of a problem. Of course, there were also restrictions. So, for example, parts directly involved in weapon systems could not be printed because of the safety aspects, and they require more research before they were allowed to do that. But this is, however, ongoing. So in the future, they expect to be able to. This, however, still left plenty of room for the benefits, as still 10 to 20% of the parts currently was estimated to be printable. And this ranges from, as you can see in the images, a custom-made clip to store weapons while driving, to large filters that are used on ships. And the early success of 3D printing, or the experiments with 3D printing, even led them to say that in the future, the military should take 3D printers on every future mission. So this speaks to the benefits and the potential of 3D printing. On to the next short innovation, blockchain. This is the final innovation I would like to discuss today. And in short, blockchain is a distributed, shared, and tamper-proof ledger. Well, in less complicated wording, this means that a blockchain is a type of database which is shared between multiple users at the same time, and which data, once added, cannot be changed. So the most well-known example of blockchain is, of course, its application in cryptocurrencies such as Bitcoin. And although Bitcoin works in the same principle as the blockchains we're interested in, this is not really the type we want to talk about today. Bitcoin and other cryptocurrencies are examples of public blockchains in which everybody can participate. So of course, for most industrial applications, this is not desirable. So for most applications in service logistics, we are looking more at the private or permissioned blockchains, in which only agreed and verified parties can participate. So to shortly explain what blockchain is, I'll highlight 3 interesting attributes of blockchain: the distributed nature of blockchains, the way a blockchain is really built, and the ability to control who has access to what. So first, a blockchain is distributed across a network of computers, which means that everyone has a complete copy of the blockchain. And this means that there is no one single party that has the sole power over the data. So no single authority has the ability to make one-sided changes to the database, and the other parties have to trust it. So that's the case in the central database structure, but in a distributed database structure, because everyone has the data, this is not possible. This also means that from a hacking standpoint of view, it's safer. Secondly, so how the blockchain is built. Well, a blockchain is built quite literally from like a chain of blocks. So each block really represents a record or a transaction, and new records that are added to the blockchain are also captured in new so-called blocks. Well, these blocks are created using complicated cryptography that ensures that the blocks once created cannot be changed or altered without changing its so-called fingerprint or hash, without also changing. So if you want to change the data inside a block, it also changes the hash or fingerprint. So this invalidates the block, the blockchain. So this ensures that data is trustworthy and verifiably not tampered with. So you always know what was in a block can be changed. Well, lastly, a blockchain can be permissioned. So this means that a blockchain is only accessible to verified participants, and certain users can have other permissions or usage rights than others. This can be, for example, very useful if there are different roles in the supply chain, or information should only be accessible to certain people. Now, the difference with a permissionless blockchain like Bitcoin is that in such a blockchain, everyone can participate. Well, these attributes make the blockchain an ideal platform to share data between parties with sometimes conflicting interests. So you can't change data in the way you like because of the way a blockchain works. So if there's conflicting interests, the blockchain is really a good way to create trust. How can we use this? Well, for example, we can use blockchain and to share information with the engineers of our equipment manufacturers to share the usage data and failure data, so they can perform root cause analysis, but also to the blockchain can also be used to store or record performance data, so that it can be used to enforce certain service level or overall equipment effectiveness agreements with your suppliers. Moreover, more on the inventory management side, a blockchain can be used to source materials. So demand for spare parts can be placed in some kind of marketplace of pre-selected suppliers, which can then bid on the order. And after a bid is selected, an automatic contract is made called a smart contract in the blockchain. This is just a digital contract that automatically triggers when certain conditions are met. So once a bid is won, for example, the order is automatically placed at the supplier, and once the order is successfully received in the warehouse, the smart contract automatically triggers the payment to the supplier. Well, however, just like with all the other innovations I've just discussed, blockchain is not necessarily the answer for every supply chain challenge or every database challenge you have. So in some of the scenarios I just shared can also be achieved without the use of the specific blockchain technology. So before implementing such a technology, it's always important to critically evaluate if blockchain is really necessary for your specific problem. So to do that, we advise to consider the following questions. So is there even a need for a shared database in the supply chain? Does it have benefits, and how will we benefit from it? So it's not beneficial to just share the data and then don't do anything with it. So you should really have a plan to benefit from it. Secondly, it's important that these parties can have conflicting interests. Otherwise, you could just share a normal database if there's no risk for any changes. So if the answer is no to any of these questions, then you should probably critically reevaluate your decision to use blockchain and use a simpler alternative. Well, after these short introductions to these innovations, we are curious to hear your opinions on their potential and also on the possible barriers. And for that, I would like to hand the word back to Henrico.
Thank you very much, Wouter. I hope everyone can still hear me. I'm going to share my screen with you for the conclusion of the webinar. Now I need to do this correctly. I want to start by thanking all the presenters again. I believe some of the audience members, as I myself, are a bit overwhelmed with all this new information, and maybe a bit futuristic look, and maybe a bit of a far reach for some. But I believe, as all the speakers has mentioned, the technology is closer than what we think. It's practical, it's implementable, and it is definitely something that can make a big difference, not one day, but today. We're going to do a quick Q&A, and to kick it off, we're going to use a bit of a poll technology. There's a few instructions on the screen, but essentially there's a link which I've also shared in the chat function with you. If you can please open the link on your internet browser, it will ask your name, and you can simply type that in and enter into the polling question, which will then lead us to 3 questions to test the functionality and to make sure everyone has got access to it. I see there's already a few answers. Just a quick indication of where you are located. And I'm aware of several of the audience members not being in South Africa. So you can either plot yourself in the sea or maybe in the northern part of the picture. But it seems there's a number of Johannesburg attendees, a few Cape Town. I see Port Elizabeth, but pardon me if I do not try and pronounce the new name. Great. There's definitely, okay, so it seems everyone is getting used to the poll questions. So maybe over to 3 quick questions. And what we try and do with these questions is allow you to open your mind and just give your opinion. Be honest and just think of it from a personal perspective. Of course, today we only discussed 4 specific innovations, but Sean touched on a number, including robotics and including remote control, etc. And there are many more. If we look at the world of innovation, it's as simple as just Googling it, and you will find a whole array of different technology out there. But not all of these are necessarily equally practical or equally financially achievable in your environment. So I think of that picture and try and answer the following question for us. And you can again go to your browser screen. But if we look at this from the value it adds in your business, which has the highest potential? And you can simply change the order. If you click on the options on the left, you'll see arrows. You can simply change the order in which they make sense to you. I see some responses popping through. It's there's 4 results coming in. It seems the order remains quite constant. More results coming in. I think being a bit time sensitive, you guys are welcome to still fill it in, but I think it becomes clear that IoT is by far the first option to many, especially looking at from an asset management perspective, trying to decrease your working capital, but also increase the life of your asset. Then we see predictions up second, and robotics, the one that we did not necessarily discuss today, but definitely I think Sean made quite a few references to robotics in third. So what I want to do is ask you basically the same question, but looking at it from a financial perspective. which one of these do you see being successfully implemented in your business, well, with the least amount of effort? Of course, there's a financial investment to all of them, but there's also a bit of change management and maybe a bit resistance you can experience. Okay, it seems the order has changed a bit. Robotics is picking up, but it seems to be equaling out with blockchain. Condition monitoring, of course, requiring the most effort, maybe financially also quite expensive, or at least the perception is there. I believe if there's questions around it, Johannes will be more than happy to answer that, but gives us an indication at least of the general feeling out there. And then the last question is simply, if you need to implement one of these, what do you think is the main obstacle that you will encounter in your business? I can't say I'm extremely surprised in the answers. Of course, and I think it's logical that change is always a challenge, especially in Africa. It's not always as easy and rapid as we often hope. So it's not surprising that we see a lot of guys saying, look, we believe in what we currently do. We don't necessarily want to change. But if we can convince them, of course, there's the financial side that needs to follow. And then, yes, technology and what we've discussed today is very much based on the top part of the spare part management roadmap, or the implementation model that Gordian believes in. And yes, your maturity does make a difference. You do need the basics in place to start optimizing with these innovations. But that being said, I'm going to hand back to our MD, Willem, to discuss and conclude on today's webinar. Thank you very much for everyone's participation. If you can just present. No, it's out. So I'm going to see.
Room for 2 questions.
Yeah.
So good day, everyone. Again, so we reached the final part of the presentation. I saw in the chat, I think, some interesting questions. And one of them is more like an ethical one. Was, how do we work? How are humans factor in? I don't know who exactly asked that question. I saw it on the chat. Sean, if you're still in, can you briefly address this question on what is the role of humans in all these innovations?
They don't have a role.
Okay.
That was a joke. It was a joke. Maybe too early for jokes. The role of humans in innovations. Well, I think the major potential is that these new innovations are doing 2 things really. They are removing a lot of the non-value activities that take up most people's time, administrative roles, repetitive work, lifting and shifting, things that effectively are part of the supply chain but don't add any real value. But they're also uncovering new business models. They're uncovering new efficiencies, new opportunities to do things better. So it's simply the ability to remove yourself away from non-value adding activities so that you can actually start on to create new value driving activities, new value propositions, new ways of doing business, completely new business models, new types of supply chain networks and designs. As you say, rather than moving goods halfway around the world, you're having things like 3D printers in missions or in particular locations where things can be printed on demand. So the role of the human gets amplified, not degraded. It gets removed from being the human's hands just being effectively flesh machines into the humans becoming, people who are much more creative, much more able to spend their time doing things that are more value adding to the organization than simply pressing buttons or lifting boxes.
Okay, thanks for your comments. And maybe I saw also an interesting question from Michael. I also see Johannes saying that he can address him later on his email address, which is on. But maybe, Johannes, maybe you can have a 30 seconds reply on his question.
Yeah, thank you, Willem. I think in short, it's about managing the lead time and the demand that happens during that lead time. So if you've got better understanding of what the potential demand is going to be, you have a better chance of not running out of stock during the lead time. It's not always easy. I'm not stating that you will never have stockouts again, but you can definitely, by improving the level of accuracy of your information, you get yourself into a better position not to run into stockouts. Currently, especially with lead times varying due to supply issues, customs issues, all due to COVID, it really highlights the importance of having accurate information as much as we can at any given time. And then if you start building in proper algorithms and potentially also adding artificial intelligence into the picture, then you can manage this much better. But yeah, it justifies probably a longer answer than 30 seconds. Thanks.
Okay, thank you.
Thank you, Johannes. I'll contact you.
Good, great. Bas, I also saw your comments on the access to the video. We will come back on that on a later stage, because as I said earlier, the video is primarily meant for internal purposes. So I will discuss it with SAPICS on a later stage. Okay, great. Well, to finalize, it is a very fair point. I see a lot of clients that are still in the basics, setting up the foundations, as you can see here on the slide. So a lot of companies have a roadway to follow. That is just a reality. But there are different ways in doing that. And what we say is you can use now it should work. Yes, you can use the Toyota Corolla speed, the BMW speed, or the Max Verstappen speed. And the speed within which you move ahead during this journey, that is really up to you. That's up to leadership and up to the management. That is what we have felt as a discriminating factor. And from my side, I would like to thank you, and I wish you a lot of success in your innovative journey in the spare supply chain. So thank you very much. And I would like to conclude with the last slide. So if you've got any questions, you see here the numbers of the email addresses. As I said, you will get a brief summary of the slides. And also, if you've got anything to say, like evaluation points, please feel free to share it with us, because we always try to learn from these kinds of events. Okay, thank you very much. This is the end of the webinar. Tonya, I don't know if you have anything to add as final statement.
Hello. That was a very, very informative session. And I think, as typically is the case, whenever Sean does a presentation, he just scares the living daylights out of people. But I think that we need to be cognizant of the fact that we are moving ahead at a rapid pace. And we need to be on it, or we need to be left behind. So, the decision is for all of us. But yeah, a very, very informative, very insightful, and very important topic is MRO and spare parts management. It's something that's far too often overlooked through the supply chain. In fact, there was a comment about it being the stepchild to supply chain management, but a very, very important component, and let's us not forget that. So thank you guys for the session. for the information. I wanted to share I can do it. There we go. So just so that everybody knows, to watch out for the SAPICS conference online this year. Obviously, we will once again be sharing exceptional content such as this webinar this morning. So watch out for it. Watch the presentations and speakers that have already been confirmed. We will have a fantastic lineup, as is always the case. So look out for that. And I'm not sure that I've seen anything yet from Gordian, so I'm hoping that will still come through. But yes, thank you for joining us. Thank you for sharing your time with us. Gordian, thank you for the exceptional webinar, and we look forward to seeing you all very soon in our next session. Thanks and goodbye.
Thank you. Goodbye.